everyone, and welcome to another Sidewalk STEM. So I'm Dr. B, and we're out here on the sidewalk. And I thought it'd be fun to look at an activity that we did at last month's Wonder Lab, which was all about air pressure. And if you or your little ones are into science, definitely check out our Wonder Lab program, where we do a lot of interactive, exciting science explorations, experiments, and demonstrations. So today what I've got here are just 2 glass jars of water. The water's the exact same temperature, and there's the same amount in each bottle. And what I've done is I've just dyed this one blue and this one red, but it's still just H2O. And what we're going to do is stick 2 bottles inverted all the way down, and we're going to watch what happens to the water that are in these 2 glass containers in regards to these bottles. This one's going to be seemingly empty, but it is full of air right now, and it's at the same air pressure as it is outdoors right now on this beautiful, lovely day. This one will also be empty and full of air, except I'm going to take this very hot water, hot enough for coffee. What I'm going to do is I'm going to very carefully pour it into this bottle like so, to get it nice and hot. Stick that over there. Then I'm just going to kind of slosh this around a bit to get this bottle nice and hot, nice and warm. And then I'm just going to pour this water out quick. And so the air in this bottle is very hot, the air in this bottle not so much. And I'm going to hold these down here, and we might do a little time speed up for the video, but we're going to wait a couple of minutes and see what happens. So the one on the right in the red water had that hot water inside of it for a little while, which made the air around it also very hot. And as air warms up and gets hot, its molecules start moving faster, its pressure increases, and the high air pressure in the bottle wants to move out to a lower pressure system, which is the air around us today on this nice sunny day. So it had a higher air pressure, and this one was just at room temperature. And what's going to happen now is we've stuck these down in here. You can see on this blue bottle, it's mostly air in there, and you can see just at the very bottom there's a little bit of water starting to creep into sort of the neck of the bottle. That's where the water is able to, as I push the bottle down in there, the water presses up and it compresses the air that's trapped in the bottle a little bit. But that air pressure inside the bottle is pretty strong, and it can only compress so much, and then it's able to resist and hold back the water. If you look at this red one here, you can see that actually the water is starting to be drawn up into the bottle, and it's actually raised above the level here, because what happened is the air was under higher pressure here. So when I stuck it in and it started to cool down, there was actually less air in the bottle. So now it's being compressed by the force of the water, and as the air continues to cool and the pressure decreases, it creates more space as the air contracts for the water in the bottle, for the water in the glass jar to start to go in and fill up the bottle. And as you can see, that's a pretty drastic difference between this bottle and the one that's in the blue water, which wasn't heated up and was at the same air pressure as the air outside around us. We'll wait another minute or so and see if that water gets even higher. It looks like as the air inside continues to cool, it's still being drawn up a little bit more into that bottle as the water presses against it. And yeah, so as you can see, if we had a bunch of ice and some cold rags around us, we could put them on this bottle, cool it down even more, lower the pressure of the air that's inside the bottle by even more, which would create more space and more opportunity for that water to continue to sort of be drawn up into the bottle as it fills the void as that air is shrinking inside there. All right, well, thank you much. Thank you for joining us for Sidewalk STEM. I'm Dr. B, and I look forward to seeing you next time.